In pre-calculus and calculus, we need to be able to identify whether a graph is increasing, decreasing, or constant. The identifying of this is actually pretty straightforward. Most of my students get this right away. So when we look at this graph, remember we always think going left to right in math. We always think in that direction. So as you're traveling on this, is this graph increasing, decreasing, or constant? It's going up, so it's increasing, right? As you travel on it, it's going up. Great. What about this one? If you look at it as you travel from left to right, are we going downhill? Oh, look, the graph is decreasing, correct? Now, if you're not increasing and you're not decreasing, you're not going up or down, you're just staying flat. So it looks like this, and this is constant. That's all there is to this, y'all. Is it increasing, decreasing, or constant? That's the easy part. Now, the hard part is how math wants you to report this. So, when reporting where a graph is increasing, decreasing, or constant, a lot of students want to talk about the y values because that's what you look at to see if it's going up or down, but that's not what we're interested in. We are going to report the x values, and we're going to do that in interval notation. Where does it start increasing? Where does it end increasing? Does it ever break in the middle while you're doing that? That is what we're reporting. So I want you to remember, we report x values. We report x values in interval notation. This is super important. So let's look at our first example here. Look at this graph. Where is it increasing? You all can probably look at it for me and go, oh, look, it is increasing from here to here. That is going uphill, right? So what do they want us to report? They don't want us to report 1 to 4. That's not it, okay? You're going to report where x value do we start increasing at. Where does this start increasing? Well, it starts increasing at -4. And then it stops increasing here. And what is that x value that it stops increasing at? That is 0. So we are increasing on the interval from -4 to 0. Now, I just blew a few minds because I put both of those in parentheses. Why did I do it that way? Well, because here at the end, is it increasing or is it decreasing right at that exact spot when there's nothing happening before it? It increases after it, but what's happening right there? It's a little bit of a gray area in math. So when I write it, I will always use parentheses. However, if you did write your answer as -4 to 0 on an exam, Mrs. Hoffman would totally take that, but my open math isn't going to take that. So when we're reporting increasing, decreasing, constant, please always use parentheses. All right, now where is this graph decreasing? Well, we can see it starts decreasing here and it ends decreasing there. Remember, what do we report? We report the x's. So where is the x where it starts decreasing? It starts decreasing at 0. And what is the x where it stops decreasing? Well, that x value is 1. So the graph is decreasing on the x values from 0 to 1. What about constant? Where is this thing flat? Well, it starts being flat here and it ends being flat here. So it starts being flat at 1 and it ends being flat at 2, 3, 4. So it is constant on 1 to 4. This also is a great time for us to look and see why are we using parentheses by looking at this spot where x equals 1. So before 1 it's decreasing, but after 1 it's constant. So what's happening exactly at 1? Is it decreasing or is it constant? I don't know. Is it both? Is it neither? We're just not sure. So that's why we use parentheses all the time when talking about increasing, decreasing, and constant. It's because those breaking spots are sort of ambiguous. So we're just going to ignore them and leave them out of the whole situation. Whereas we're very sure immediately after the number 1, this thing is constant. So we can say definitely right after it. And so we use it as the endpoint, but use a parentheses. Now, one of the issues that some of my students have is they want to stop the increasing whenever they see a bend. So is this graph right here increasing over this interval right here from -2 to 2? Yes. Is it still increasing from 2 to 4? Well, yes. Is it increasing before 2? Yes. Is it increasing after 2? Yes. That must mean it's increasing at 2 as well. Just because it changes speed of increasing, it's slow here and it's faster here, doesn't mean we break it. So when I would look at this graph, if I wanted to say, where is this graph increasing? I would say it's increasing from -2 all the way to 4, and I wouldn't need to break it up at that 2. Just because it kind of changes how fast it's increasing, it's still increasing that whole time. But the second graph is different. Why is it different? It's that when you look at when x equals 2, the y value here is a hole. It doesn't exist. So when there's a hole, nothing is happening. There's just nothing. You cannot include that as part of the domain. So at that number 2, it's not increasing either. It's just a hole. It doesn't exist. You have fallen to the center of the earth. So when I want to talk about increasing on this problem, I am going to say, well, it's increasing from x is -2 to x is 2, but then the whole graph just breaks. And then we're increasing again from x is 2 to x is 4 afterwards. But we can't include that 2 because there's nothing there. So the increasing on this one is going to be from -2 to 2, and then from 2 to 4. So when there's a hole, you have to leave that x value out. But if it's just bending, it can still be part of the increasing. So just try to pay attention and keep those two things in mind. The last thing we need to be able to do is identify from a table, is a graph increasing or decreasing? So what you want to do is make sure your x, or your whatever your independent variable is that you're going up. So 3, 10, 21, 43, 55, that's in going up on the x's. So as the x's are going up, think of it as going this way on the number line, so moving left to right, just like we wanted to. What is happening to these y values? 5, 102, 135. What is happening to these? They're increasing. They are going up, correct? So this graph is increasing. It's pretty straightforward to see. Now, let's look at this second graph. As we go up in the x's, so as we move right on the x-axis, what is happening to the number of hair follicles here? Well, that is going down. So this function is decreasing. Pretty straightforward, but you do need to sort of pay attention to which direction are your x values going.